All right, let me put it up here. So if we're trying to figure out how to solve these types of problems, these problems here, let's go into number 1. Count. Thank you. Count how often x appears. Okay? So, if x appears once, okay, that would mean, for instance, y equals 4x squared minus 2. Okay? You use inverse operations. Okay, now those of you that struggle, you're like, okay, inverse operations, I've heard it, I can't quite remember. Remember, that just means after you set y equal to 0, because you're looking for an x-intercept, so y always becomes 0, you just do opposites. Add 2, divide by 4, take the root, and it's plus minus. I took the root of both the numerator and denominator. That's how I got the 2 on the bottom. Root of 4 is 2. Those are my 2 answers. All right? That's number 1. So x appears once. You guys may put your notes a bit different than I do, but I'm just kind of making up the notes as we go on this one. Okay? If it appears more than once, all right? If it appears more than once, and so the situations become that it has a constant or it doesn't have a constant. So without a constant or another variable, but right now you won't see other variables with it. So without a constant. Okay, so for instance, you would have, say, let's pick one off our assignment. Where is our assignment? You'd say like have number 20 or number 13 off your assignment. So y equals negative 2x to the 5th plus x cubed. Okay, you have this. You don't have another like a plus 5 or anything at the end. You set that equal to 0. And at that point, you are using factoring. You're factoring out a greatest common factor. And that greatest common factor should contain x, because x appears in each term. So in this case, you look at your degree. Your lowest degree is 3, so that means I can pull out an x cubed. And when I pull out an x cubed times x squared is x to the 5th, and you still need that negative 2. And x cubed times x cubed, or x cubed times 1 is x cubed. You now have 2 pieces you can factor, or excuse me, that you factored. And those 2 pieces, this times this, must equal 0. So that means each of these parts gets set equal to 0. And that becomes your solutions. From there, now you go back to step 1, where x appears only once. Everyone see that? So you're really just progressing. You went from easy to more difficult, but the more difficult breaks down back to the easy, the step 1, the first part. Okay, and here now you're just, sorry, that should be equal to 0. Now you're just solving. That's 0, x has to be 0. On this one, you subtract 1, divide by negative 2, and take the root. So negative 2x squared equals negative 1. Divide by negative 2, you get 1/2, and then take the root. X is equal to plus minus root 1/2. Now usually we rationalize that. I would probably have you round that to the nearest tenth right now just because we're going to use these eventually to graph. But if you're not going to round it, then you would rationalize, and I'm not worried about rationalizing right now, where you'd have root 2 over 2, okay? But there and there. All right? Another example for those, like another example of this one would be, say, like number 20. So let me show you 20 because some of you be struggling with that one. Where you had y equals x squared plus x minus 6. This part becomes 0. X, excuse me, that wasn't the one I wanted. I wanted 16 because we have a, let me put that on a different page. Let's do that. I don't want the constant yet, so let's do 16 instead. Okay? So another one where you have only x's. You don't have a constant. So x appears more than once. In fact, it appears 3 times here in 3 different terms. Okay? But you don't have a constant in there. Okay? So we set it equal to 0. You look at it and go, well, x can come out of each of these. The smallest degree is what? It's 1. So we pull out x. X times x squared. And we need the 2. X times negative 3x, and x times 1. And don't forget that 1 back there. That's a key piece. Okay? Because at this point now, you look at it and you go, all right, well, I set that equal to 0. And that's one answer. And then I set this equal to 0. Now, when I set 2x squared minus 3x plus 1 equal to 0, that gives me a situation where I don't have x's. I can't use inverse operations. What have we done with these types of problems? Factor. Yeah. Factor, right? You could factor. What else could we do? Quadratic formula. Okay. Completing the square. Graphing. You can use your calculator. I mean, you have all these different options we can use. We did a whole chapter on that. Obviously, for most people, the factoring is the quickest one. 2 times 1 is 2. 2 things that multiply to make 2 and add to negative 3. Negative 2, negative 1. Divide by a. Don't forget to divide by a. That's the key piece when you have that a term. So you get negative 1 and negative 1/2. Okay, so we get x minus 1 and 2x minus 1. And now you set that equal to 0. That's 1, and that is 1/2. Or, once you get here, if you just flip the signs, those are your answers. Okay? So my 3 answers here, remember, this is a cubic. I could have 3 potential answers. My 3 answers, x equals 0, x equals 1, and x equals 1/2. Okay. So questions there. All right, so really what we've done with this is we've hit all parts now. Because by covering this piece right here, this is what you do when you have multiple x's and a constant. Right? So when I say x appears more than once without a constant, well, if it appears more than once with a constant, okay, appears more than once with a constant, that would be like number 20, where you have y equals x squared plus x minus 6. You can't pull out an x because there's no x on that one. So here you're using, so again, factor, quadratic formula, completing the square, graphing, any of those options that we've had. You use any of those. This one factors really well, right? This is x plus 3, x plus 3, x minus 2. That means x equals negative 3 and x equals 2. All right. That should address all the types of problems that were on that page, with the exception of 1, 2, and 4. Okay? And quite honestly, with 1, 2, and 4, I'm not going to stress out about those quite yet. On 2, I would use my graphing calculator. Put it in there and calculate your zeros. We talked about that yesterday. Number 1, you could use your graphing calculator, or if you felt really good about using factor by grouping, you could do that. Now, if you're struggling with this, don't try to do factor by grouping yet. We can come back to that. Just put it in your graphing calculator. Number 4, real quick, on that one, we have x to the 4th negative 13x squared plus 36. Let me work through that one with you. Because yesterday I said, hey, we'll go to imagination land and deal with that. Well, let's, thank you. Let's not use imagination land. Let's actually go through and factor that. If this power is double that power, you could think of this as 0 equals x squared to the 2nd power. Right? Because that's x to the 4th. Everyone with me? You now have a quadratic. Right? If I didn't tell you there's an x squared in there, you'd be like, oh, okay, that's a quadratic. Everyone with me? Okay, and this is actually minus 13x. You guys with me? X squared, excuse me, to the 1st power. Okay, now, once again, my variable x squared is just like my x. All right? So like, Dylan, you were asking about this yesterday. You're like, I didn't get it. When you said we had to go to imagination, well, this is the mathematics behind it. Okay? So when you look at this, you're still asking the same question. It looks weird, but you're saying two things that multiply to make 36 and add to negative 13. And those two things happen to be 9 and 4. Negative 9 and negative 4. It's just rather than putting x out here, that's not what's being squared. X squared is being squared, so we got to put x squared. You guys with me there? That's mathematically what's happening. So from there, this becomes x squared minus 9 equals 0. That's x squared equals 9, and x equals plus minus 3. And this becomes x squared minus 4 equals 0, x squared equals 4, and x equals plus minus 2. Can you get there? All right. So there we go. Questions? That's a real slow review of yesterday's stuff. All right. I would encourage you, if you struggle with yesterday, to really watch the video lesson again over break. Okay, even tonight. All right, maybe clarify a bit. Okay.